Hi, welcome to the Parents Math Tutor. I'm a Texas-based teacher with over 21 years of experience. The most common question I get every year from parents is that they don't understand how to do their child's math homework. So that's why I'm here. I'm here to help you and your child get better at math. It's like free math tutoring. Leave a like and subscribe, and let's get into the lesson. Hi parents, welcome back to another episode of the Parents Math Tutor. We are getting ready to jump into a big one. Today we're going to start addition and subtraction. We're just going to do 2 digits today, so just up to 99. And in this video, I'm not going to model regrouping. I'll do another video for regrouping because it's kind of a lot for one little piece of time sitting and watching the computer. So we're going to get into the hows and whys of why we do math a little bit differently in school nowadays than when you and I were little. Let's go ahead and jump into it. So they call it new math. It's not really new math. It's just a new way of showing your math thinking. And so why? Why do we do math a little differently nowadays in school than when you and I were younger? Okay, well, when I was little and it was time to learn addition and subtraction, I memorized a formula where I stacked one number on top of another number, and I just went through a series of steps that my teacher had modeled over and over again, and eventually got a final answer. If I did the steps out of order, if I forgot one of the steps, if I did the step wrong, or she modeled it wrong, or I learned it wrong, I would get the wrong answer, and that was just that. So you and I learned rote memorization of math formulas when we were little. Nowadays, because we have such a focus on number sense, truly understanding that we can break apart numbers, we can move them around to make our math thinking more easy for us, we really truly have a flexible point of view, a flexible thinking point of view when it comes to solving math. So, and that leads me into my next point. Each child you encounter has a different learning style. So even though the formula that I memorized when I was little, I eventually learned it correctly and I grew up to be a perfectly functioning adult, I was able to learn by watching someone model and copying them. But there are kids who don't learn best that way. There are kids that learn by touching objects in front of them. There are kids that learn better by drawing pictures of what they see. There are kids that learn better by listening. There are kids that learn better by watching. There are kids who learn better by actually doing and writing it with their hand. And if we're just teaching one formula, we're probably reaching one type of learner. If we're teaching a flexible approach to math and a flexible way to show your thinking in any way that you can, we're reaching all learning styles, which means that kids will feel more successful, they won't feel as frustrated, and they will learn the harder concepts later on easier than if we were just teaching them formula after formula. One of the most common misconceptions that I get each year is I have students come into my classroom and tell me that their older sister taught them how to stack the numbers, or their mom and dad showed them how to stack the numbers. And when it comes to addition and subtraction in my classroom, they try to stack and they have some misunderstandings. The sibling might have shown them how to do it wrong or out of order. They might have watched their parents do it right, but they didn't understand what their parents were doing. And so they're mimicking the concept of stacking, but they'll go upside down. They'll start in the tens place. They'll forget they're subtracting, and they come out with the wrong answer more often than not. So if you truly are teaching a number sense approach to math, that's going to help the students understand how to break the numbers apart and put them back together in a way that makes sense to them. Also, when we get to regrouping, which I won't model in this video, I'm going to model it in the next video. But when we get to regrouping, you will see that it gets a little bit more complicated when you have to move a whole group of tens from the ones place to the tens place, or when you need to regroup a number from the tens in order to subtract in the ones. When you're just doing a memorized stacking formula, you're going to get the wrong answer more often than not. So, why do we teach new math the way we teach it? It's because we want the children to have a true, deep knowledge of numbers and not just a memorized formula. Okay, you know that in every video I talk about how important vocabulary is. And when I was typing this list, I was just like, wow. I have 7 and 8-year-olds that come into my classroom, and most of them speak more than one language, but they all speak English. And then I get them in my classroom and I'm expecting them to learn a whole nother language on top of the language they already speak, because these are purely academic words. I use them often when I'm teaching, and if the child doesn't understand what word I'm saying, it's going to make math so much harder. So some of them that I thought of for this topic are addition, subtraction, sum, difference, regrouping, joining and separating, story problem, addend, and strategies. These are words that I don't use in social language with the kids. I only use in a mathematic context. Notice at the bottom, I wrote 2 words. I wrote the words borrowing and carrying. These are words that we used when we learned how to stack numbers when I was little, and they don't have much meaning at all, other than like you're carrying a number to the other side of the numbers that you stacked. But the number that you're carrying, you're not even writing how much it's actually worth. You're just writing a digit. And so that pertains to just the formula you're doing. Borrowing has a little bit more meaning, but I like to use the word regrouping for both of these words instead. Because when you're regrouping a number, you're making a new group. You might be making a group of 10. You might be making a group of 100. You might be taking a 50 and changing it into a 40 and a 10, or a 30 and a 20. You're making a new group. So instead of using these words, borrowing and carrying, I use the word regrouping for everything, because it maintains its meaning whether I'm drawing a picture, whether I'm on a number line, or whether I'm using expanded form. So I'm excited. Let's get into seeing how to teach addition and subtraction without regrouping, not by stacking the numbers. All right, our first example today is going to be 56 plus 33. When I was a kid, our teacher would have had us stack it like this, and we would have seen the 6 as a 6, the 3 as a 3, the 5 as a 5, and the 3 as the 3. And we wouldn't have known the value or cared about the value of any of the numbers. So I'm going to show you 3 different ways that kids nowadays in school could possibly show their work to get the answer to 56 plus 33. Not by stacking, but by relying on those place value strategies that I talked about in my original place value video. The first strategy I'm going to show you is called the expanded form strategy. It is similar to stacking, but we retain all values of all numbers so we can always see them. So we're going to break both numbers into expanded form, 50 plus 6, and we're going to break the second number into 30 plus 3. And then I'm going to make sure I write the plus sign over to the side, and I'm going to break it into a tens column and a ones column to keep those numbers together. I do always want to start in the ones place, just in case there's regrouping. So 6 plus 3 equals 9. And 50 plus 30 equals 80. 80 plus 9 is the expanded form of 89. Notice how that goes back to the foundation of the place value skills that we learned originally. Expanded form is one of the ways to represent the numbers. That's why we need that strong foundation of place value. Okay, the next strategy I'm going to show you is going to be on a number line. So I'm going to draw a number line across the bottom of my screen. And we know that number lines always go from least to greatest, and so we're adding. So I just want to put the first number at the beginning of my number line because I know my answer is going to be bigger because I'm doing addition. That'll be different for subtraction. But I'm going to go ahead and plot 56 on this number line. And in order to use a number line as a tool for adding, I need to break 33 into easy to add chunks that I can jump on the number line to add. One of the things I always teach my students is that 10 is a friendly number. So anytime we can break a number into its tens, we want to be able to do that. So 33 would then be equal to 10 plus 10 plus 10 plus 3. Do you see how I can break apart that number however I need to make adding easy? It doesn't have to be a 33. So to show this on a number line, adding by tens is quite simple. We practice this on the hundreds chart all the time. You're just changing the digit in the tens place by 1 going higher. So instead of a 50, it would be a 60. So 56 plus 10 would equal 66. And then 66 plus 10 would equal 76. Okay, we've used 2 of our tens, so I've got 1 more. 76 plus 10 is going to equal 86. And then with that 3, I could do 1 jump of 3 if that was easy for me, or I can do 3 jumps of 1. So that's what I'm going to do. I'm going to do 86 plus 1 plus 1 plus 1. 86 plus 1 is 87. 87 plus 1 is 88. And 88 plus 1 is 89. That's a really good sign that I got the same answer on my number line the way that I got it in expanded form. The last strategy that I want to show you is great for kids who are strong at art and who love pictures. If you remember in my place value video, we showed you pictorial model of numbers. So just like in the expanded form strategy, we're going to represent the numbers that we see using a pictorial model. So I'm going to draw 5 rods and 6 units for 56. And then I'm going to draw 3 rods and 3 units for 33. And then this time I'm going to start with my rods. I'm going to count them together. So I count by tens, 10, 20, 30, 40, 50, 60, 70, 80. I have 8 rods. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 units. All right, so now we're looking at subtraction. I'm going to show you the same 3 strategies with subtraction that I showed you with addition and show you just how they look a little bit different when you're doing the opposite operation. So let's go ahead and start with expanded form. I'm going to write 76 as 70 plus 6. I'm going to write 32 as 30 plus 2. I always write the operation symbol outside to the left-hand side of my expanded form just so I don't forget what I'm doing. So I wrote my subtraction sign. I've got my tens place and my ones place. 6 minus 2 equals 4. So I'm going to record the 4 at the bottom of the ones place. 70 minus 30 equals 40. So I'm going to record that at the bottom of the tens place. And then 40 plus 4 in expanded form is equal to 44. All right, the expanded form for subtraction without regrouping was very similar to addition, but I'm going to show you the number line next. The number line is going to be very different because when you're subtracting, you're starting with a bigger number and getting smaller. So I actually have to put the first number in this equation at the right end of the number line because I'm going to be hopping backwards to get the smaller answer. So I'm going to plot 76 on my number line, and now I want to figure out how to break up 32 into easy to subtract chunks. So I told you that I like tens. Tens are a friendly number. So I'm going to break 32 into 10 plus 10 plus 10 plus 2. Very similar to our first example. So when I'm subtracting a 10 from a number, I'm going to make the tens place go down one digit. So let's go ahead and start at 76, and we're going to subtract 10, and that equals 66. Then I'm going to subtract another jump of 10. That's 56. And so far I've used 2 of my tens. I need to keep track, so I've got one more to go. 56 minus 10 equals 46. Again, that 2, if I'm comfortable subtracting a 2 in my head, I could just do that. I could go from 46 down to 44, but it depends on your child. If your child has a hard time doing that backwards, then you might just want to break it up into 2 jumps of 1, and so that's what I'm going to do. I'm going to do 46 minus 1, and then that minus 1. So 46 minus 1 is 45. 45 minus 1 is 44. I was able to, with number sense, break those numbers apart and make them make sense for me. Okay, and the last strategy is still pictorial model, and this is different because in addition I drew both of the numbers in pictorial model. But in this one, I'm just taking 76 and taking 32 away from that picture. So I only need to draw 76. So I'm going to draw 7 rods and 6 units. And then I'm going to cross out 32 from the picture. So I'm going to cross out 10, 20, 30, 1, 2. And what I have left over is 4 rods. And I also have 4 units left over. And so every time I did this problem, I got the answer 44 with flexible thinking and representing numbers in different ways. I hope you join me next time for regrouping, because that is probably the biggest hurdle that I face as an elementary school teacher. Thank you so much for joining me. Thank you so much for joining me today. Please leave a like and a subscribe. It really helps the channel grow, and maybe it'll help other parents help their children with their math homework. We'll see you next time.